Okay, hi everybody. Welcome to Programming Fundamentals. It's week 3, talk B, and we're on the Programming Fundamentals. Okay, so as always, if you're taking the class live, give us a thumbs up. If you're watching on demand later, just press the video so we know that you're after taking the session and we know who we're dealing with. So in our last class, we were looking at methods. Breaking our problem down into sub-problems is really what methods enable us to do. Um, we looked at three different types or three parts to the signature. We have the return type, the name, and the parameters, and we've been practicing writing various methods to help us understand that. And when we write our own methods, up to now we've been generally calling methods, with the exception of writing setup and draw. Those two are also methods. Your calling methods, you don't have to worry about how they're implemented. But now we're starting to get into the point of, well, what goes inside a method or a function, okay? And where you write the statements to solve the problem of a method is inside the body. So we have this concept of a method call, which is what we've been doing a lot of, calling line and rectangle and so on. And then the definition, where you write the inners of the method, and that was set up and draw. So lots of examples this week. And we asked you to take a look at the I's and the X's outside of class. We made up a video to show you different variations on how that was done and to explain them. And you'll see those again in the lab for today's class. So hopefully you've managed to get to that. And we also then, in our exercises, looking at red rectangles and parameters to change size and location. So the concept of not just draw a rectangle, but pass in some additional information which determines how the rectangle will be drawn. So this is the concept of a parameter. And then the slightly more difficult one, which is returning a value. So when a method does something and gives you back an answer. So for example, we looked at times 2. So you took in a number, it multiplies it by 2 and gives you back the answer. And that answer is usually then stored from wherever the method is called, or it's used inside of a condition. Okay. So again, just to highlight the I's videos and the X's videos, which are examples of more methods. And it's important that you've taken a look at those. And if I just switch to here, we can see where they are. So we're asking you to take a look at method examples for the I's and also the X's. So some short videos there that will take you through that. And you may need to look at them and practice them more than once. Okay. So on to today's class. Today we're looking at methods, writing more of our own ones. So I'm going to take one you're familiar with, which is the eye. We're going to create a grid of eyes. We're going to look at converting from Celsius to Fahrenheit. Once you know a formula, how can you use a formula in a method to return an answer? And some more examples of returning a value, because that's the one that's been causing the most trouble when I look at the questions on Slack. So product, calculating the product of a number, calculating the cube of a number. So we'll take a look at those methods. We'll highlight debugging again. We'll move on to overloading, which is a special feature in object-oriented programs for methods. And we'll mention recursion. We'll take a look at it, but I don't want you to worry about it too much. But we will show it to you so that we are complete in discussing methods. And finally, we'll move on to strings, manipulating strings. And this will be useful for you in your upcoming assignment. Now, I'm not going to give out the assignment today. As I've mentioned, I'm going to wait till the weekend, give you all a chance to complete today's class, the labs, the exercises, and the challenges. And that will set you up in really good stead then for tackling the assignment, which you'll have 2 full weeks to complete. Okay. So I'll just switch here for a second. If there's any questions, as always, please post them into the Slack channel. Okay. So I'm going to do some recaps on the I's and X's so that we can use them in creating the grid. And then we'll move on to the converter, the overloading, and the recursion. Let's start with the I's again. So you should have seen this when you were looking at that additional content before class. Drawing a single eye. So here we have setup and draw. This is how you might have tackled it without knowing about methods. All our code goes in the draw routine and we draw a single eye. But we were able to then put that code into an eye method, which is here, and then we were able to call it more than once. So it's more efficient. Instead of having to repeat the 6 lines of code, we can just call it once. So this is nice and efficient, and we can draw then an eye in multiple locations. We then expanded on that and we drew 6 eyes. Again, just changing the parameters. And what I'd like to take a look at now is how we might use that eye method from here on the right hand side of the screen. So I'm going to use this eye method and we're going to call it multiple times, just like we did here, by hard coding the values. But we're going to see, what if we could get rid of those hard coded numbers and replace them with variables or equations? So where we've been using variables is in loops. So if we take a look here, we can see we have a draw method, background clearing the screen and setting it to gray. And then we have a nested for loop. So this is a for loop inside a for loop. So what's going to happen is it's going to count rows. It's going to start at 1, then go to 2, then go to 3. And for each one of those rows, it's going to create 5 columns. So we're counting from 1 up to 5 every time, incrementing the counter. And then we're drawing the eye by calling the eye method. And I suppose that's the important bit. Just here. So we're calling the method eye, and we're passing into it 2 values. And the first value is the X coordinate, and the second value is the Y coordinate. So, apologies for that. Let's get that going again. So, if we look at this part here, we're saying count multiply by 60. So my count is going from 1 to 5, and we're saying multiply the 1 by 60, then multiply 2 by 60, multiply 3 by 60, 4 by 60, and 5 by 60. So this is giving us the distance across each time. So this point here is over 60. This is going to be 120, 180, 240, and 300. And this gives us the X position to draw the eye in. And then the row then is, what's the current value of row? So it's either going to be 1, 2, or 3 multiplied by 70. So again, I just change that. We're saying the row is down 70 for the first eye. It's going to be down 140 for the second one, and 210 for the third. So we're using the loop counter variables multiplying them by some number, manipulating that number in some way in order to figure out where we want to draw our eye. Okay? Okay. So I'm just going to put you on hold for a second. Okay, apologies for the pause there. So that's creating a grid of eyes. We highlighted the debug process. Let's just go through it formally. We can turn on the debugger by pressing the debug in the top right hand corner. And when you do that, it's going to give you now 4 buttons instead of the traditional 2. It also opens up your variables window. Part of debugging is to set a breakpoint. And you can see if you click on a line number, it will give you a diamond, and that diamond is called a breakpoint. And what it means is when you're stepping through your code, the program will pause at this point where you can then examine the values of all the variables in the computer's memory. And then you can click continue or step either of the first 2 buttons to continue on your way and continue running the code. So here we're seeing row is 1 and count is 1. And this folder here represents processing, and these are the system variables. Again, stepping into just brings you around, in our case, bringing us around the for loop. Okay, so we might take a look at that, and I'll share the code with you as well, and you can try it out for yourselves. Where are we? Processing. Okay. So let me share that with you in Slack. And that's in Slack now, so you can copy out this example program and try it out for yourself. When we run the program, it creates this grid. But what you might want to do is to then try out our debugger and put in some breakpoints. So if I put a breakpoint every time it draws an eye, we can see what's going on. So first of all, turn on the debugger. Gives us that pop-up variables window. Then we can click on the line number to create or toggle the breakpoint. And if I just do that, let's see what happens. So it's run the program. It hasn't drawn an eye yet. It's gone into the draw method, run the for loop, the inner for loop, and it's just about to draw an eye. So my row is 1 and my count is 1. Okay, so watch what happens. So we're going to step and step, and you can now see it working its way around the for loop. So row is 1, count is 1, 2, 3, 4, and 5, and in the background it's drawing the eyes. Okay. Then when the counter falls out of the inner loop, we go back out to the outer loop. Notice that the count variable no longer exists because it has block scope. We're in the outer loop, and we're going to increment row, which makes it 2. And now we're creating another for loop. And as part of creating that new for loop, it's going to recreate the count variable, which we'll see. There's the count variable in my output window after being created, and it's now back at 1. And then it's going to step through that 1, 2, 3, 4, and 5. Okay. And then at the end, it'll exit out of that loop, killing the counter variable. It's no longer in memory. And we're out at the outer loop, and now we're ready to increment row again. Row goes to 3, and now we can step through 1, 2, 3, 4, and 5. Okay. So at that stage, it comes back around. Count is 5. It's going to be added to 1, so it becomes 6, and then it'll fall out of the loop because it won't meet the condition count less than or equal to 5. Okay. Likewise, row is now gone outside the bounds, so it exits, and now we're out at the end of the draw method. Now it's doing that, and it's calling all of that code 60 times a second because that code is inside the draw method. Okay, but it allows you to see how the variables are created. It allows you to see their scope, when they're created and when they're destroyed, and also to see what the values of the loop counter variables are for both the inner and outer loops. So I'd encourage you to spend some time working your way through that. I have encouraged you to use pen and paper to work it out beforehand, but this is a nice way of seeing it. And of course, you can also, if you weren't using the debugger, you could also do this. So inside here, we could also use the print statement. A warning about the print statement and the print line statement. These statements are only for putting out to the console. And what that means is it's not part of your official output, if you like, of the code. So we don't use the print line statement to create a program that's displaying anything. Okay, the display window is what we see. The print line statement is really only for developers. So when you're developing your code, you can see what's going on. So for example, I could put row plus, put in a comma and a plus, and then we'll put in count. And the idea of doing that is that in the output, you can see the loop, how it's working. Okay. And you can resize that console as well just by dragging it up. Okay. So it's constantly writing out because the code is being called in the draw method, and the draw method is called 60 times a second. So it's having to print out all the rows and all the columns 60 times a second. Okay. All right. So where I posted the code, you might just send me a screenshot of you running it, please. Just make sure that everybody's okay with that. And if you're having trouble, please let me know. Okay, good stuff. Thanks, Ignis. So this is quite an efficient way of sharing code, just like I did a moment ago. If you are posting in Slack, rather than posting a screenshot with your code, if you're looking for help, it's often a good idea to add a text snippet. Okay, and if you create a text snippet and paste your code into it, it's usually a lot easier for people to help you if you are stuck on anything. Okay, so there's the creating a text snippet. When you hit the plus, it's going to give you that in Slack. Okay, that's good. Everybody's still with me. Excellent. Okay, so let's move it on then. Um, and we're going to add a little piece of code to what you've already got. And I'd like you to type this in yourself. And the idea here is you can save the display window as a graphics image file by writing some code to do it. Okay. So what we're going to do is we're going to use the mouse clicked event, which again we saw the last day. So it's mouse clicked, and I'm saying save my display in all formats. And that's just a name I made up myself. Okay, this is the name of a method that I'm going to write myself. Save my display in all formats. So I'm not quite sure how we're going to save those graphics at this moment in time. What I do know is that when I click on the mouse, I want it to save image files in different file formats. So now let's look at how we might implement that. Well, I am writing my own method. My method is called save my display in all formats. I've commented here using multi-line comments. So graphics file formats, common ones are PNG and JPEG, which you'll see a lot in web development. But you'll also come across TIFFs and Targa files, TGAs. And these are much larger files. These are older file formats that would have been used on computer systems in years gone by. They're also uncompressed. So a TIFF file is something that would have been used in, for example, early digital cameras. Would have created very large files, but with the advantage that they were uncompressed. So large files, but no distortion that you get with JPEG, for example. So processing makes it very easy to save files, and it's saving your display window by using the save function. Now this is built into processing. It's called save. You pass in a file name, and it works out from the file extension what type of file format you want. If you wanted to save it into a subfolder, you can do that by specifying the subfolder / and then the name of the file. Okay. So let's help you with that as well. So I'm going to share this bit with you as well. So I've just posted in Slack save file format, some code. I'd like you to take that code and I want you to put that into the code that you're working on at the moment, save grid. So we're going to add this much and you'll be able to see it working. So again, this is a mouse handler, which we've seen already, mouse clicked. When I click on the mouse, I want to call this method. This method is one I'm writing myself. And I do that by saying void. It doesn't return any value. It also doesn't take in any parameter at the moment. It's just called saved my display in all formats. And then here I'm showing how I might save it in PNG, JPEG, TIFF, and Targa. And if you run the program now, and you click, it will actually save 4 graphics files representing this output display. Probably a good idea to know where you're saving. So let's save my file first. I'm in week 3. And let's call this grid, EyeGrid. And I'm going to save. So now I've saved my sketch. Save as. Let's do that again. And then we'll run it. And then we'll bring up the folder in where I've saved that. So it's in my processing, 2022, week 3. Here's my EyeGrid. And now you can see the PDE file is the source code. And the first line saves a ping file. There it is, just created now. If I double click on it, you can see it's actually saved my output as an image. And I also showed you how you could create a subfolder. So even if the subfolder doesn't exist, it'll create it. And in there, I've saved a JPEG, a Targa, and a TIFF file. Okay, so what I'd like you to do is to, again, just take a screenshot of this on your system so I can see that you're keeping up with this. Okay. So I've just replied to the thread, post your folder contents for image here. We'll give you a chance to get that done. So this is going to be particularly useful for you guys when it comes to doing the assignment. This is going to be one of the things that you're going to be required to do. Okay, thanks for that. All looks like everything's coming together okay there. Excellent. Okay, so we'll move on. So we also have the X's example. The X's example drew 3 X's on the screen. We have the light grey one, the black one, and the white one. If we hard code it, we get a very long draw method. What we did is we took that and split it up, put the code into the draw X method, and we parameterized it by taking in parameters for the color in grayscale, for the weight, the X and Y position, and also the size. And then we use those parameters inside of the draw X method to be able to abstract away the hard-coded values and to enable us to then pass in those hard-coded values in a draw X call, and then we can again reuse that by making more calls to draw X or including it in a loop, for example. So here we're saying once we know how to draw 1X and we've parameterized it all, we just need to change the parameters to draw different types of X's. Okay, so much more efficient. So with both the I's and the X's, what we saw was there is no return value. Making a return value seems to be causing some trouble. So we're going to take a look at Celsius to Fahrenheit converter. Okay. So the previous 2 method examples didn't return a value, so the return type was void. Now we consider an example where the method does return a value. But in this next example, we're going to return a float. So setup, if we were to do Celsius, Fahrenheit to Celsius converter, we would say that the Celsius value equals, make a call to the method and pass in your Fahrenheit value. And it's going to figure out then using some equation what the answer is, and it's going to come back and store the answer in the variable Celsius. We can then print out that value on the next line. So when we call the Fahrenheit to Celsius method, we have to then define what goes inside it. So let's work our way through it. The word float is the return type. So we're saying when you make this calculation, it's going to end up as being a decimal number. So that's why we use float instead of int. The name is Fahrenheit to Celsius. That's the name of the method. And then inside brackets, we put, if you like, our parameter list, which is similar to how we declare variables. So we have a data type followed by the parameter name. Data type is float, so it's taking in a decimal number. We're going to call that decimal number it takes in, calling it Fahrenheit. And then we can use it inside here to work out the answer. So if you look up or do a Google, you can find out how do you convert Fahrenheit values to Celsius. And you'll get an equation similar to this. It's the Fahrenheit minus 32 multiplied by 5/9. Okay, so all we've done is taken the traditional formula and written it as computer code. We've parameterized the value Fahrenheit 32, so minus, put all of that in brackets, multiplied by, and then in brackets 5 divided by 9, or 5.0 divided by 9.0. So that's going to work out the result. And then the important line here, this is what's new. When you want to return a value or have a method that returns a value, you need to use the return statement. Okay? So we're using return the result. So here's what happens. The 451 gets passed into this method when we run this line here. Let me get that up. Here we go. So when we run the setup, the first line of code is this. Float Celsius equals Fahrenheit to Celsius. So that's going to call the Fahrenheit to Celsius method definition. It's going to pass in this parameter 451 into the parameter Fahrenheit. So then inside of here, we are saying 451.0 minus 32, work out that answer, then multiply it by 5 divided by 9, and the answer you get, you want to put into result. Result is a local variable. It's created at this moment in time, and it's initialized to be this value. We can then return result, and what returning result does is it says, I'm finished with this method. So the answer that you worked out, whatever result is, it's passed back up. Get rid of that. It's passed back up to here. So whatever your answer is on the right-hand side of an assignment statement now. And then that answer gets put into the Celsius variable. Okay, so let's go through it. 451. So we 451 minus 32 multiplied by 5/9 is 232.77779. So that result gets passed back up, and ultimately Celsius becomes 232.77779. We then print that out with the print line statement, and that will be printed out to the console just like this. Okay. So this is an example of having a method that returns a value. Now, we could even simplify that further. I said there's always more than one way of writing a computer program. 2 plus 2 is 4. 1 plus 3 is 4, which is the more correct way. It doesn't really matter. So we can also look at doing it this way. Instead of creating the local variable result, we could get rid of using result altogether and just use return whatever this works out to be. So the formula is the same as before. The method is the same as before. But instead of creating a local variable to store the result in and then returning the result, we're just saying in the second example here, return whatever the equation works out to be. And both of those will give you the same result and the same answer. Let's try another one. This one is cubed. So what we're going to do is take a number and cube it. And cubing it means we are multiplying it by itself and itself again. Okay. So we have setup. This time I'm just to get away from writing to the console. We're using text and fill and text size. So in setup, I'm just sizing the window. This is an important number, 1024 by 768. And another important numbers are 1280 by 720. These are numbers that are common in display sizes. So if we're going to save our display and we create the output window the same size as the display, it means we'll capture everything that's on the computer screen. It also means that if you go to combine all these images and they're all the same size, it makes for an easier production later. So our size, 1024 by 768. The text size is set to 40. It's effectively the font size. Text size is how we do that. Fill is set to blue. And having done that, we then call the draw method. Inside the draw method, we're initializing number to be 5. And then we've got a text message, outputting to the display. And what are we outputting? We're saying number plus cubed is plus, and then I'm calling cubed 5. Okay. And where am I putting that? I'm putting it at 100, 100. So this location is 100, 100. And what am I putting out? I'm putting out this text string. So I'm saying 5 cubed is, and then I'm calling this method that I have to write myself. So cubed is a method where it takes in a number and it multiplies the number by itself twice. Okay, so it's num by num by num by num, and then returning that back. So this is an example of a method that returns an integer. And it'll work for small numbers. You'll probably get an error if you put in an integer at the biggest size of an integer. So maybe you might want to change that to be a long integer or a long. But for simple purposes, this is fine. Okay, so again, we have the return type. We have the parameter num. And when we call it from here, we are calling cubed 5, so we're passing 5 in to the method, and then that 5 is going to be used to calculate the result. So it's 5 by 5 by 5, which works out to be 125, and 125 is what's returned. So 125 gets passed back up to where it was called from. So now our string is number, which is 5, cubed is, and then the answer for cubed 5 is 125. That whole string is outputted to the display at 100, 100, the location, X and Y coordinates. Okay, so I'll just pause there. Some questions coming in, I think. No. Okay, we'll come back to them. Here's another example. This one's product. Hang on a sec. Can you call the method before the method call? Okay, so let's come back to here. So I had a question. Question is, can you call the method before the method call? Can you call the method before the method call? I think what you mean is, can I put the method above, if I get that right? Um, so you can define your methods anywhere in the file, and you can then they will be found when you make the call. I hope that answers your. Yeah, okay, that's great. Thanks, Ian. And let's see, we have another one here. So we have a question from previous example. So we'll jump back to here. This one. So the question is, are we saving any computer resources by doing the second method and not assigning the extra variable? Or is the compiler smart enough to do that for us? Um, I would say that this is simpler code to follow. You are creating a local variable with the first one. Um, so I would say that the second is preferable. Okay. I hope that answers that for you, Ignis. Thanks. Keep the questions coming. Okay, so I'm going to move on to product. Here's product. So again, as in the previous example, we have a setup, setting the size, text size, and fill. And then in the draw method, we're going to again output to the screen. This time we're working with floats. So we have A and B, and we're outputting A. The product of A and B is, and then call the method product. Now, product is just multiplying one number by the other number. Okay. So because we want to work with floats, we've got a float num1 and we have a float num2. Okay. And then inside, we are returning num1 multiplied by num2. That's what product means. When we multiply those two numbers, we're giving back a float number. So that's why this is not void. We're saying give back a decimal number. Again, it's probably more correct to make that a double, because if you had two float numbers that were the maximum size and you multiply the two of them together, they wouldn't fit inside a float. So you'd have to have a bigger data type to store the number. So double is probably more accurate. But again, just for what we're doing at the moment, I think it's okay. Okay. So again, return type and the parameters num1 and num2. So we're seeing lots of different examples there of how to return values. Okay, so what have we been doing? We've been looking at the particular method definitions that have been causing trouble. Returning a value from a method. Why do we need to do that? And when we see more and more examples, we'll see why we might want to do them. Initially, when we started writing methods, it was just draw stuff on the screen or output to the display. But more often than not, you want to write a method to solve some problem and give you back an answer. And when you're doing that, that means you're using a return type. It's going to give you a return value. Therefore, it has a return statement in it. Okay, and hopefully you're getting a little bit more comfortable with that concept now. Okay, let's take a pause there for a sec and get set up here. Okay. Okay, so next up is overloading. And let's take a look at that now. Okay, so we're talking about methods. And when we talk about methods and object-oriented programming, the concept of overloading comes up. So let's see what that means. So overloaded methods. We have multiple methods can have the same name once they have a different parameter list. In earlier examples, we wrote the following methods. So if you're following the draw x example we did, uh, you will have seen that we had draw x with no parameters, draw x with one parameter, draw x with two parameters, and we worked our way up to draw x with 5 different parameters. So these are all examples of an overloaded method. This is just terminology that we need to be familiar with. What I'm saying is, if you have different methods, all with the same name, and the only thing that's different about them is the parameter list, then you are talking about the same overloaded method. In other words, they have the same name, the method is the same name, it's draw x in every case, but what's different is the parameters that we're passing in. Okay, so same name, but different parameter list. So if we look at the first one, it has no parameter. The second one has an integer parameter. The third one has 2 integer parameters. And the fourth example has 5 integer parameters. Same name, but different parameter list. Program can have 2 or more methods with the same name only if the parameter list is different. When Java is checking that a parameter list is different, it's not checking the name of the variables, it's checking the data type of the variables. So for example, this is permitted as the data type is different, i.e. void draw x int gray and void draw x float gray. So because the parameter name is the same, we don't care about that. What we care about is that the data type of the parameters are different. Okay, and that way they are all each version of draw x is unique. I'm going to go back to here because questions come in. Do we need to call the parameters in a certain order, or can we define them ourselves? You must, when you're calling the method draw x, pass in the correct order. Okay, because otherwise you're going to be supplying values that you think mean one thing, but the method is using them in a different way. So for example, if we have this example, void draw x int gray and int weight, and you don't pass them in the correct order, the number that you pass in for the weight is going to be used for the grayscale color, and the number that you use for the grayscale color is going to be used for the weight. So yes, the order is important. Okay. So data types must be different for a method with the same name to be overloaded. So let's take a look at this one. We have background 204, we're calling draw x and we're passing in 0. Which draw x method is called and why? So we have 2 of them over on the far side. Top one is the first, bottom one is the second. Let's do this in Slack. Which draw x is called? And if you wouldn't mind replying. Yeah, it's the one with the int, correct? The first one, top. Uh, both is not the correct answer. It can only call one method. Okay, so the draw x here, what happens is it looks at the value that you're passing in. And the value you're passing in is 0, which is an integer. It's a whole number. And if we look at the two versions of draw x that we have, one takes an integer and the other one takes a float. Both of them only take one parameter, but how the computer distinguishes between the two of them is that we are passing in a whole number. So it would choose the top one, okay? As in this one here. Okay. Okay, so most people got that right. Hopefully you understand why it's not both. It can only call one of them and it has to figure out which one to call. Okay. Overload the methods. When you call a method, Java matches the number and type of arguments you pass to the method with all the declared methods. When a match is found, Java invokes that method. For example, draw0 calls draw x int gray, and draw 0.0 calls the second one, the float gray. Okay, so that's overloaded methods. And it's really a piece of terminology that we just need to be familiar with. We're able to create lots of methods. Now what we said is you can create methods that have the same name, but you're just creating different versions of the same method. And where you've seen overloading, from day one, so it's not a new concept to you. It's just a new term. Where you've seen that was when we looked at color. So you might remember setting the color by specifying a single number, and that was the grayscale. And then you learned about RGB values, so you could specify 3 numbers. And then you learned about hexadecimal version, so you had a fourth. And we also saw another version where we could specify RGB and alpha. And I want to remind you of that one. Again, will be very useful for your upcoming assignment. So specifying a color with an alpha is the transparency. The fourth number specifies the transparency. Question here, can overloaded methods have different return types? That's a great question. So we said that what makes an overloaded method is that it's got the same name but a different parameter list. And what makes the parameter list different is the data types. I'm going to leave that one open. I want you to try it out and see what happens. Okay, and I might do that during the break. And I'm going to leave that question open. So what the question is, thanks Owen. The question is, can overloaded methods have different return types? So what I'd like you to do is just take the example that we've just gone through and change the return type and see what happens. Okay, and you tell me. Okay, I have one more thing just before we do break. So bear with me for 1 sec. And then we'll have a good place to break. Just one more thing to look at, and that is recursion. This will be quite short. Okay, so we're going to look at recursion. So this was the 5th topic on our table of contents from our start of today's class. Here we've got draw lines for a loop, for loop. So we've seen this before. We have setup, sets up the output window. We have draw lines 10, 4. So it's calling the method draw lines, passing in 10 and the number 4. Okay. Here we're using a for loop. For int is assigned a value 0. Keep going while I is less than the number of lines. decrementing the number of lines. So num lines minus minus. So instead of counting up the way, we're counting back the way. And we're drawing a line at the X start position, which is the number we passed in, comma 20. That's the first point in our line. And the second point is num lines. So X start, comma 80. So this is giving us a vertical line. And then we're updating the starting position by 5. So that's going to add 5, and that allows us to draw another line here. So if we look at this, this is the way we would normally code it. But what we want to do is introduce the concept of recursion. And what recursion is about is it's a method can contain a line of code that calls itself. So you're defining a problem in terms of the problem itself. And if you keep doing that, you never get to the end. So it has to have something special in it, and that's called a base case. So to stop infinite calling of the method, it's necessary to have some way for the method to exit, i.e. the base case. So you continually work backwards towards the base case. Let's have a look. Here we have a different way of writing a method. Now, again, don't worry if this is if you find this troublesome. I'm highlighting it here. We don't use it a lot, but I do want to cover it. So what my base case is I'm going to say keep going until the number is greater than 1. If the number is greater than 1, we can do this. If it's not greater than 1, then we're finished. So we're taking in draw lines 10 and 4. Let's work our way through it. So the 10 and the 4 come in here. We're drawing a line, and then we're testing if the number is greater than 1. So draw lines 10, 4 says the X is 10, the number is 4, the number being 4 is greater than 1. So I'm going to call draw lines again, i.e. this bit here is going to get called again. So we're writing a method, and as part of solving the problem, we're calling that method again. And this is called recursion. So what happens is we end up calling draw lines with X plus 5. So it's now 15. And our number has been decremented. So it's now 3. So we're calling draw lines with 15, 3. And it draws the second line in the output. It'll then come to the if statement. The if statement says if num is greater than 1, well, number is 3, which is greater than 1. So it's going to call draw lines again. But it's after adding 5 to X, and it's after decrementing the number to 2. So we're calling draw lines with 20, 2. So it draws the line and then does a test. Is the number greater than 1? Well, the number is 2, which is greater than 1. So we'll go off and call it again. This time we're calling draw lines with 25 and 1. Draws the line. Then it checks if the number is greater than 1. Now at this stage, the number is 1. It's not greater than 1. So it's not going to draw another line. Because number is 1, X is 25, it's not greater than 1, so it's not going to call draw lines again. This is our base case. So our base case has been met. So at this stage, what we do is we finish calling that method and return to the previous call of the method. And we do that all the way back up. So having reached the base case, we return back up. The call stack is referred to the original call. So we got our 4 lines drawn out without using a loop, but we were using recursion. Okay, so that's a can be quite a difficult one to get your head around, and I wouldn't worry about it. You're not going to see it again after this example, really, or after this week's lab. You won't see it again. You may like to write your code this way. Most people don't. Okay. All right. So this is just returning up the call stack. So that's it. We've gone through what I want to cover with methods with you now, and we're going to take a breather at this stage. I think it's a good place to stop. When we come back after the break, we're going to be talking about strings, manipulating text, functions that we can use, or methods that we can use to manipulate text on the screen. Okay, so just bear with me, and let's put up some time on the clock. And if you have that question that I've asked you to work on, can overloaded methods have different return types? So put in some methods, try them out, change the return type, and give me back the answer. Okay. Okay. Right. So we'll take a breather there. We're back at past. Okay. Okay, guys, let's get started again. Okay. So we had a question just before the break there. Can overloaded methods have different return types? And so I posed some help there. If we had two methods called add, and they are overloaded, so they take in different, first one takes in integers and the second one takes in floats, and you're going to add those up together, they would have to actually return different types. Okay. So the answer is that yes, you can have different return types for overloaded methods. Okay. I see there's some further discussion coming in there. We'll take a look at that a little bit later. Okay. Good to see the discussion going and keep the questions coming. Okay. Right. So we've got about half an hour left. Let's see if we can get through strings today. Okay. So when we talk about strings, we're talking about text on the screen. And we need to clarify one thing first, and that is to do with the character data type. So we have a character, which is a primitive type, and we have string, which is an object type. And this is the first time we're really talking about objects. For your first assignment, you're only allowed to use the string object. You're not allowed to use any other objects. Okay. We'll be doing the rest of our course will be to do with object types, so we'll get plenty of exposure to it. So today we're going to look at the difference between primitive types versus object types. We're going to look at strings in the Java API. Specifically, we're going to look at some methods that you might find useful to call in order to manipulate text. And we're going to introduce this concept of dot notation by looking at method calls, which we've been doing for this week. But we're going to distinguish between internal calls and external calls. So there's a lot of slides there that's talking about dot notation. And once you've used dot notation, it's actually a lot simpler than all the documentation that explains it. Using it is actually a hell of a lot easier. And then at the end, we'll fire through quite a few different examples then of using string methods, using the dot notation to see how we can make use of it in our programs and specifically in our assignment. Okay, so let's start with the character. So the char data type or char data type. Java programming language supports 8 primitive data types. These are the keywords that are used: byte, short, int long, float double, and char and boolean. We've gone through these previously, right? So there's nothing new here. The character data type stores one single character, which is delimited by single quotes. So we've seen an example before. Char letter is assigned a value A. The A goes in single quotes. So these are valid character declarations. We have char letter equals or is assigned a value single quotes small n. And the second one is an uppercase n. And these are different values for letter. Here's an invalid use. So it's best to have a look at where you might go wrong. If you say char letter is assigned a value n, you're saying letter gets the is actually what that's saying is it gets the value of the variable n, which we haven't declared. Next one, char letter is assigned a value double quotes n. You can't say this because that's actually a string and it won't fit in a character data type. And the last one, char letter is assigned a value not. Again, this is a string. You can only hold one character in the char data type. So char is a 16-bit Unicode character. Its values range from, and we have \u 4 zeros to \u 4 f's. And that means you got 65,535 different characters that can be represented. Now, in the old days in computing, we used to have something called the ASCII character set. And that was grand if you were in Western Europe or if you're in America. You could store all the symbols that you wanted to put on the computer. But computers are used the world over. So what happens when you want to represent the Chinese alphabet system or the Indian alphabet system, or accented E's and F's and so on? So we needed to be able to represent the alphabets of the world, but be able to store each of those characters in something called a char. So the character data type allows us to do that, and it's facilitated by this system called Unicode. So I just want to have a quick little look at that. There's a link here that will bring you to it, and I think I have it ready. But yeah, let me just switch there for a sec and get that ready for you. Switch out of full screen and we're back to here. Here we go. So the link will bring you to here, and you can see we've got the Unicode character table, and you can search on various elements. So you can look for emojis, and you're familiar with this from your mobile phone. So we can click on a particular set, for example, smileys. And if we highlight a particular one, it gives us the Unicode value. So this is U1F600, 1F642. Okay. You can also see you can get the HTML code for it, and that might be useful for you in web development. So the fact that each one of these symbols has a number means that, for example, we could write a loop to print out all of these once we know that the first one starts here, and we initialize the loop to be this value, and then we count this many times, whatever it is, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we'll get all the smiling face emojis. That might be an example you try later tonight. Print out all the smiling face emojis from the Unicode character set. Okay. Swap it around a little bit here. There we go. So now you have a better understanding of what these examples mean. Okay, so we have /u 0041 /u 0061. So let's look at that example that I was asking you to consider. Here we have car letter is assigned value A, and then we have a loop going from 1 to 26. There's 26 letters in the alphabet. That's where the 26 comes from. But what I'm doing is I'm saying print out letter, and the first letter was A, and then the next 26 letters are going to be printed out because I'm using letter plus plus. So I'm adding 1 to letter. We're saying letter is a character, but I can add 1 to it, because really what's stored in that character in double quotes is that number. And you're adding 1 to the actual number that gives you that picture. So that's a nice one to try out. Okay, and let's just read through this. The code uses the underlying Unicode value for A, which is 0041. It adds 1 to it each time the for loop is iterated. And as the for loop is iterated 26 times, and the starting value is A, the loop is going to print out the entire alphabet to the console. So you're going to get this. Okay. So that's the car data type. And I suppose exercise then is I want you to try, and I'm going to put this into Slack, try print out the smiley faces of the Unicode character set based on what I was showing you in the web browser a second ago. Okay, so that's one for you to try out. So your code is going to be similar to what we've got here, except you can initialize it to be /u and then the number for the first smiley face. Then count how many smiley faces are in it, in that character set. And then you know how big to make the loop, so you can change the 26 to whatever number that was. Okay, so that's one for you to try out. Right, so next is object types, and we want to introduce strings. So strings, which are widely used in Java programming, are a sequence of characters enclosed by double quotes. So, for example, double quotes, sequence of characters. In Java, a string is an object type. The Java platform provides the string class to create and manipulate strings. The most direct way to create a string is to write string with a capital S, greeting to represent the variable name, equals, or is assigned a value, hello world in double quotes. And you've done this already. The key thing here, though, is that the string is an object, not a primitive data type. If it had been int, float, char, they were all lowercase. Because it's an object, the string is an uppercase s. You use a lowercase s, you're going to get a syntax error. So here's some valid uses of strings. I'm a sentence in double quotes. String word, assigned a value dog, in double quotes. String letter is assigned a value A, and even though it's only one letter, that's still considered a string because it's surrounded by double quotes. Where you're going to go wrong is if you forget to put double quotes around. Again, if we had a variable n and n was a string, this first one here would be okay. This one here would be okay, but we're just going to assume that what's happened here is you've left out the double quotes. Second one, string letter is assigned a value single quotes n. That's going to make it into a character, so that's not going to work. And the third one is the one that's going to get you, right? This is the gotcha. If you use a lowercase s and you say string letter is assigned a value, double quotes n, it's not going to work because the string object type has to be represented with a capital S. So it's case sensitive. Please make a note of that one because we're going to have a lot of questions popping up in Slack when people get that wrong. Okay. So the rule is object data types start with a capital letter to distinguish them from primitive data types which start with lowercase letters. Again, we're distinguishing between and introducing object types today. So let's look at the difference between a primitive type and an object type. Here's a primitive type, integer. We're creating a variable I, and we're going to initialize it to 17. So that's stored directly in memory. We have a box in memory, and we put 17 into the box. We call that box I. When we have an object type, and we say string hi is assigned a value hello, what actually happens is this. The hi variable contains a reference or an address to where the string is stored in memory. So we don't put hello into the box. Hello is in memory, and we get the address of where it's stored in memory. I'm representing that here by ampersand ffcc. So the hi variable is the address of where the string is stored. Okay, so if you like, if you've come from another language, it's effectively a pointer. So the variable just needs to store the pointer to where the actual value is stored in memory. So that's a subtle difference there. With primitive type variables, int, float, char, etc., we have what's on top. The value is of the variable is stored in the memory location assigned to the variable. And with object types, with object types, the variable holds the memory address where the object is located, not the value inside the object. So now that we know how primitive types and object types store data, we'll look at the statement B is assigned the value A in the context of primitive and object types. So for primitive types, for example, int A, if we say B is assigned the value A, that would create a box and put that value into that box. So B is assigned the value A, says, well, what's the number stored for A? It's 17, so we put 17 in the box for B. That's what we've been working on up to now. But it's different when it comes to object types. So let's say B and A here are objects. They're string objects. So we have string A is storing hello at the address FB3B. We're storing the address in the A variable, the A object variable, of where the word hello is stored in memory. When we say B is assigned the value A, here's what happens. For B, rather than copying hello, we copy the address of where hello is stored. So hello is only stored once in memory. And for A, we're storing that address of where it's stored, and likewise for B. In other words, the reference is stored rather than the value. Again, comparing it to the previous one, on the bottom, we have primitive types. On the top, we have object types. So with object types, we're storing addresses. With primitive types, we're storing values. Okay. So that's a little subtle difference. And we just need to know about that before we move on and actually start using them. As I said, using them is going to be a lot easier than wading through the theory. So I think we just start using them. So let's get that ready for you and we'll crack on with that. Okay, so strings in the Java API. So variables created with the string data type are called objects. Objects are software structures that combine variables with methods that operate on those variables. For example, every string object has a built-in method that can capitalize letters. So here's the link to the Java API version 8. There's also version 11 and many versions after. We are not staying on the very latest version because for what we're doing, we're only getting we're only hitting the basics, so we don't need the latest greatest API. And by going to the latest greatest API, it's going to break some stuff that you do in web development. So we're staying a couple of versions behind, but for what we're going to cover, it's more than enough. So if we take a look at this link, this is the documentation for the Java API. API stands for Application Programming Interface. Basically, it's a library which documents uh, all the classes that are used and all the things that you can call. So you can see here we've got lots of them. Okay, so there's objects or classes created to allow you to do lots and lots of different things in Java. You can see later for working with databases, we have SQL, there's sound, lots of different stuff in here. And we can go into any one of these and then we can find out about that class. Now, lots of documentation, and I'd like you to take some time to find your way around it. Okay. If you just want to go straight to the string methods, you can follow this link and it'll get you there a bit quicker. So we're now looking at the string class and we can see the methods by clicking on method. And now we can see all of the different methods that we have available for working with strings. There's lots of them in there. Okay, so I'm just scrolling just to show you where they are. And let's just maybe take a look at one. Right. So what this is saying is this is the return type for a method called char at. It's going to give you the character at. It takes in an integer index, so one parameter. And the documentation is telling you that this is going to return the character value at a specified index. Here's another example, Boolean. This returns, so the return type is Boolean and the method is called contains and it takes in a character sequence. So this is checking if you have a string within a string. Returns true if and only if this string contains the specified sequence of character values. If you want to test if two strings are the same, you can use the equals. Here's another one. Index of returns the index within the string of the first occurrence of the specified character. So if you have a string object, you can call the index of method, specifying a particular character, and it'll tell you at what position that character is in the string. One you'll use a lot, length. So it returns an integer. The method name is length, and it's going to tell you the length of a particular string. So you can peruse through those in your own time and identify some that you might want to use. I've summarized them at the end of today's class on the last remaining slide, so hopefully we'll get to that now. Okay. So that's the JDK version 8. 11 is what we're actually using in the labs, and for the remainder of the semester we won't be going beyond 11. But 8 is more than enough to be looking at. Okay. So string methods. This table effectively is a summary of what you've just seen, with the more important ones are the ones you use more regularly. So we have length, which returns the length of a string. To lowercase converts a particular string to lowercase. Likewise for uppercase. Trim removes the leading and trailing white spaces before and after a string. Substring returns a string that is a substring of the one you're working on. And char at, we just looked at, returns the character value at a specified index. So these are the most common ones. And you can see there's a hell of a lot more. And this is the case for any of the objects that you're going to look at in the library. There's lots and lots of methods after being written that you can just call You don't have to write them and define them. You just call them, and it does the hard work for you. So how do you call them? And that brings us into method calls. So up to now, we've been doing internal method calls. We're going to take a look at the issue for an external method call. External because we're calling an external library. And that brings us to the dot notation. So let's just work our way through this. So to use built-in methods, we must first understand the difference between internal method calls and external method calls. Here's an internal method call. When you call a method, what you've been doing today and all week, draw X, passing in 0. What you're doing is you're calling a method that is already in the same file. It's already in the same sketch. Okay. So the method calls the method definition or invokes it. The code inside is run, and then it returns back to where it was called from. So draw x0 is a method call. Sketch has a method with the following signature or header, and it invokes that method. As the method's in the same sketch file as the call of the method, we call it an internal method call. Internal method calls have the syntax method name, parameter list. That's how you call a method. Okay, as I said, a bit of vocabulary really going on here. So we're just working our way through this vocab and theory. External method calls then. This is where we want to move to. We want to check the length of this string. So we have a variable called name, which is an object variable string of type string, and it's initialized to Joe Soap. Looking at the string API, we can see that we have a length method, which we've just looked at. So how do I call the length method in the string API to work out the length of my variable name? So in this case, we're going to make a call to a method of another object. And this is an external method call. External method calls have the syntax object.methodName. To find out the length of the string, its string name equals Joe Soap. So that's the variable set up. And now we want to make a call to find out the length of that. So the name of the variable here is name. And down here we're saying name dot length. So this is the object. The object is name. Object variable is name. We're using the dot symbol. And then the method name that we want to call. So we know it's a string object. So we want to call the dot length method of it. So object dot method name. There's no parameters in this one. It just gives you back the length. So we're using dot notation. The syntax is object.methodName parameter list. It consists of the object name, the dot, and the length. Parameters, if there are any, in this case there's none. Okay, so this is a particularly important one. This slide here, probably should have put a star on it. Again, you use it all the time once you know about it, but I'll just pop that into Slack just as a reminder to people. This is the dot notation. This is how you're going to call all the methods in the string library. So that's the theory. Now let's take a look at some actual examples. So here I've got a simple 2-line program. We're declaring message as being a variable. I'm initializing it to this text and saying how many characters are in that string. So if I say message, the name of the variable, dot length, bracket, because I'm calling a method, it's going to return 33, which is the number of characters in that string. Of course, you can combine that then, just as you have with all your other methods. You can say, for example, it is, in double quotes, in the print statement, message.length plus characters long, and then the 33 gets popped in there. In this example, We can take the string that we initialized as being lowercase or mixed case and just convert everything to uppercase. We do that by saying message dot to uppercase, and look what happens in my output. All those characters get converted to uppercase. You don't have to figure that out because you're using the string library. Here, we're taking the message and converting it all to lowercase, because remember we had a capital I, and you'll notice in the output it's now small I. So here we've got another example. Message.trim will remove any leading spaces. So if we look up at the top, just up here, you can see we have some spaces in the double quotes and again some spaces at the end. So the trim will remove all of those spaces. If I look at the output, there's the original message, 33 characters long. If I trim it, we get rid of those leading and trailing spaces, and then the length is only 24 characters long. Okay, so we've gone through strings by looking at the character data type. Then we looked at object types. We compared primitive and object types there. We looked at the Java API, specifically the string class. And we explored some of the methods that you can call in the string class. And in order to do that, we had to learn about dot notation, how we make calls to external libraries. And we finished up by looking at quite a few examples then of calling string methods. Okay, so that takes us to the end of today's class, and that's great. We're spot on. If you have any questions on any of that, I know there's a lot in there, and maybe you need some time to digest it first. That's fine. But what I would say our next step is for you to do the labs. If you've already done the first lab for this week, that's fantastic. You'll find the second one probably a lot easier. Certainly it'll go a lot quicker. And having completed the second lab, you're then ready for your assignment. I am waiting till the weekend to hand out the assignment because I want people to catch up. Okay. It's really important that you catch up. Also, just want to point out at this stage, with quite a few people in the class who are not engaging in Slack, and that's fine. But when it comes to assignment time, you're going to be lost. If you're not in Slack, you're going to be lost. So this is just a heads up. You need to be keeping an eye on Slack. Any changes to the spec, any questions, they're going to be answered in Slack. They're not going to be answered in the classes or in any further notes. They're going to be answered in Slack. I'm going to set up an assignment channel, and we're going to post a video. I'm going to do an interview with Laura to help you manage your assignment over the next 2 weeks. Please don't overthink it. It's not a big project. It's only worth 15% overall. So give it the time it deserves and no more. Okay, you should be able to complete it in the next week, but you have 2 weeks to actually get it all done. We've got a very detailed spec. The idea of the detailed spec is to anticipate all your questions and try answer them before you even ask them. Okay, so don't be put off by the size of the assignment. When you read it, what you actually have to do is quite small, but it is very precise. Okay, so you'll get the details of that on Sunday. Okay, so I'm going to stop there, and thanks very much. I'll hang back in Zoom if anybody wants to have a chat with me. Okay, thanks guys.